Okay, this video is about rational expressions and adding, subtracting, multiplying, and dividing rational expressions. So at the end of this, hopefully you're able to do all those things. We're also going to talk about complex fractions, which is really just a combination of different strategies that we learned before that when we add, subtract, multiply, and divide rational expressions. All right, what you're going to see here is just is kind of applies to all operations on rational expressions, but we're going to talk about it in the context of multiplication first. The very first thing you should do when any rational expression is to attempt to see if you can factor it. Factoring is just what we learn to do with polynomials or even just numbers, and what it's going to let us do is cancel things. So if we can simplify the rational expression, it's going to make working with it, any operation, substantially easier. Okay, so for example, right, if I had 20 thirds times 7 eighths, we know how to deal with this because we took math, we took elementary school math, and so we know that we could just multiply fractions across and say that's 140 divided by 24. But the problem with this is that it's not simplified, and so we have these larger numbers that are more difficult to factor that we're going to have to now factor and then simplify. So I mean, I see that 4 can come out 140, and if you take 4 out of 140, it's 35, and if you take a 4 out of 24, it's 6. But you might not have seen that right away, and then we'd be left with an answer of 35/6. Well, and we still get the same answer. It's totally fine to do this, but you will find that every single time when we're dealing with rational expressions that it's better to simplify first. So what would that look like? Well, we could rewrite 20 as 4 times 5. Right? That's the best factorization we can get. 20 and 3 doesn't factor, it's prime. 7 is prime, and 8 is 2 times 4. And then what we can say is, oh hey, look, these both have a 4 in them, right? So those 4s, 4 divided by 4 is 1, so it's not going to be consequential to the answer to this multiplication problem here. And then we can just say, all right, 5 times 7 is 35, and 3 times 2 is 6. So we're factoring smaller numbers, canceling, and then multiplying. It can be really helpful. Here's an example of that. Okay, so what we can do, what we would want to do first here is factor if we can. So we know y plus 3 divided by y. Neither of those terms factor, but on the next term, y squared, the way you would factor that is like y times y. And then y squared minus 9, that's a difference of perfect squares, so that's like y minus 3 times y plus 3. Okay, and then we can look, oh hey, this y plus 3 and this y plus 3, if we divide those, it's 1. Okay, so that's great. This y and this y can cancel, and so that's just 1. And then this, what's left over, is y divided by y minus 3. Now, so something to pay attention to here, and you may or may not need to do this depending on what your teacher says, but this problem, the expression itself and the simplified expression after we multiplied the product, they have restrictions. In math, one thing we cannot do is divide by 0, and since we're dealing with rational things here, we're going to have denominators, so denominators can't be 0. And we need to look at the original problem here. So if we look at this original problem, y cannot equal 0 right there. Here, y cannot equal 3 or negative 3. If it was, we'd be dividing by 0 in the original problem. It doesn't matter if y was 3, right? Then we'd have 9 minus 9, I'd have 0. So I'd have something that was okay over here, but I can't multiply something that's okay by something that's undefined. So all of these things would be restrictions and for this problem. Again, you might not need to mention these, but it's a good thing to think about as you're going through stuff like this. Right, here's an example of a multiplication problem where there's a lot of factoring involved, but it's not necessarily difficult factoring. But if we didn't factor first, we'd have these horrible 4th degree polynomials if we multiplied everything across, because you'd have to do the advanced distributive property of multiplication by multiplying a trinomial by a trinomial. So instead, if we factor first and we say, well, this is x minus x plus 7 times x minus 3. This is x minus 8 times x plus 2. This one is, let's see, x. I'm kind of doing these really quick. You might not be able to do them this quick. That's totally fine. X minus 5 times x minus 3. This one would be x plus 7, x plus 2. Ooh, now we can look at simplifying. So x plus 7 and x plus 7. This x, wait, is that it? Oh my goodness, okay, that's it. So there's not a ton of there's unfortunately not a ton of canceling we can do here. So then we just write what's left over. We'd have x minus 3 times, we have x minus 3 quantity squared times x minus 5 up top. And on the bottom we'd have x minus 8 times x plus 2 quantity squared on the bottom. And that would be it. Now we could say again that x cannot equal positive 8. Okay, x cannot equal 2, negative 2, x cannot equal negative 7, because if it did, we'd be dividing by 0, which we can't do. Okay, and then one more here. If we did, actually go ahead and try this on your own, and I'll show the answer. I won't go through it myself. All right, there's the answer to that. It simplifies down to x plus 4 divided by x plus 2. Right, dividing rational expressions is the same thing as multiplying rational expressions. All the same rules apply, except for the one thing that we need to do is flip. And what that means is basically this. If we think of a real simple version of this, if we had x divided by 1/2, well, another way to say this would just be 2x, because instead of dividing by a fraction, we can multiply by the reciprocal. And what we're doing here in this division problem is we're dividing by a fraction. We essentially have a to the 4th minus b to the 4th divided by 3a minus 3b divided by a squared plus b squared divided by 3. And if we apply this here, if we apply this thinking to this, what we'll really end up with is a to the 4th minus b to the 4th divided by 3a minus 3b multiplied by the reciprocal of this. Okay, so 3 times a squared plus b squared. Right, at this point we can factor. Okay, so we can say that this is a difference of squares, so this would be a squared plus b squared times a squared minus b squared. And this is, if we take that 3 out, it's 3 times a minus b. And then this is a squared. These don't factor, but we're not quite done yet. We'll simplify it first, though. So we can say that these 3's would divide, and it'd be 1. This a squared plus b squared would divide, and it'd be 1. So what would be left over is a squared minus b squared divided by a minus b. But we're not quite done here because this is a difference of perfect squares on top. So we could say that that's a minus b times a plus b, or a divided by a minus b. And so these two are the same, so they cancel out, they divide to be 1, and so we're left now with just a plus b. And again, we could say that a cannot equal b, because if a equaled b, this would be 0. And so that's a restriction. We could say we would also have technically, right, if this term, if this equaled 0, then we would have a divide by 0 situation too. And that would happen if a and b were equal to each other. So a cannot equal b. Okay, adding and subtracting rational expressions, although addition and subtraction are kind of like the easier things to do than multiplication and division when we're talking about just the standard arithmetic, they're actually more complicated for rational expressions. And the reason for that is because of the necessity to have a lowest common denominator. So we have, or not a lowest common denominator, but a common denominator, and we should always strive for the lowest common denominator because we don't want to overcomplicate things. In this problem here, just like if we had 1/2 minus 2/2 minus 4/2 or something like that, right? Maybe this is a little too simple, but essentially this is just 1 minus 2 minus 4 all divided by 2. So this would be, what would that be? Negative 5/2. Okay, same thing here. So we could say that this is going to be 1 minus 3n minus 2 plus n. Notice the parentheses around the 3n minus 2 is because it's in the entire numerator of this term is being subtracted. And then the common denominator being n minus 2 makes this simple. So this would simplify down to 1 minus 3n plus 2 if we distribute that negative, plus n divided by n minus 2. And then finally, to combine the m's, we have negative 2n plus 3 divided by n minus 2. And n cannot be 2. Right, now here's one that it looks like at first glance that we don't have common denominators, and we don't really, but what we can do is manipulate things. So what we can say here, and this is a common trick that you might see, 3 3 times x minus 3 divided by, sorry, x minus 5. What if we factored a negative 1 out of this denominator? Well, then we'd have minus 2 divided by negative 1. If we take a negative 1 out of the 5, it'd have negative 5. If we take a negative 1 out of the negative x, I have x. So x minus 5. And then this negative and this negative, it's like a minus a negative is like adding, isn't it? So we could say that that is like 3 divided by x minus 5 plus, my handwriting is on another level today, 2 divided by x minus 5, or 5 divided by x minus 5. So sometimes it's worth looking to see if what you have is just a negative version, and if it is on the denominator, if it is, you can take a negative out. Okay, now complex fractions. Okay, these complex fractions are just a division problem, and there's two different ways to attack these. What you can do is look at the lowest common denominator individually, and this would be like a sort of a precise method. So if we look at the lowest common denominator of the numerator of this problem, so for these two terms, what's the lowest common denominator? It's 6, right? So we're going to get that lowest common denominator by multiplying this one by 2 over 2. Then we would have 1 6 plus 2 6 on top. And on the bottom, what's the lowest common denominator between 2 and 5? It's 10. So I'd have to multiply this by 5 over 5 to get to 10, this by 2 over 2. And I'd have 5 tenths plus 2 tenths. Then I can go and simplify the numerator and the denominator. So just add these together. I have 3 6. Add these together. I have 7 tenths. And then, just like before, this is the same thing as 3 6 times 10 sevenths, right? 3 6 obviously is just 1/2 too, so I could simplify that right now if I wanted to. In fact, I do want to, so I'm just going to say that that's 1/2. So then this is just 10 14ths. Oh, but then, right, these have 2 in common, so the answer is 5 sevenths. Oof, sorry, 5 sevenths. So that's the answer. That's great. Now another way to do this would be, okay, let's rewrite the problem real quick. We had 1 6 plus 1/3 divided by 1/2 plus 1/5, and this is like the nuke method. I'm going to look at every single denominator in this problem and say, what is the lowest common denominator between all of those things? So I'm looking specifically, I'm looking at 6, 3, 2, and 5. What number has 6, 3, 2, and 5 as a factor? That would be the lowest common denominator there. So that would be 30, right? 3, 6, 2, and 5 are all 30 is divisible by all of those numbers. So we're going to get them all in terms of 30. Actually, we're not. We're going to multiply the entire problem by 30. So the numerator and denominator by 30. What that does for us is says, okay, what is 1 6 times 30? It's 5. What is 1/3 times 30? It's 10. What is 1/2 times 30? 15. What is 1/5 times 30? It's 6. So we're left with 15 21sts. Oh, we don't have any more there's no more fractions in the numerator, no more fractions in the denominator. Now all we need to do is simplify that. Of course, the answer, if we take out a 3, is 5 sevenths. So obviously we expect that because it's the same as this. But this method, you will find, is preferred almost all the time, except for when we have really, really complicated overall lowest common denominators. Here's an example of one where you don't need anything like that. This is just to multiply, to divide by a fraction, multiply by a reciprocal. So this would be m divided by 8 times 8 divided by 5m. Okay, the 8's, they'll divide to be 1. The m's divide to be 1. This answer then is just 1/5. Okay, and m cannot be 0. If m was 0, we would have a problem with this. Alright, so pause the video here. This problem here is pretty complicated, and I'll go over it, but try to get this on your own. So what I would do for this one is probably get an overall lowest common denominator. Actually, for this one, let's just get a common denominator and a numerator and a denominator. So method number 1, and see if we can solve it that way. So the lowest common denominator, the numerator, is going to be c times 3 minus 3c, right? We can't do it. There's no better way to do that. So what would I have to multiply the first thing by? I would have to multiply it by 3 minus 3c divided by 3 minus 3c. In this term, I'd have to multiply it by c over c. And when I do that, I will have on the top, I will have 3 minus 3c divided by c times 3 minus 3c minus c divided by c times 3 minus 3c. Same thing in the numerator. The overall lowest common denominator in the numerator would be c times 1 minus c. So I would have to multiply this, the 1 over 1 minus c, by c over c, and this one by 1 minus c over 1 minus c. And so then I will have, in the denominator, I will have c divided by c times 1 minus c, and then minus 3 times 1 minus c divided by c times 1 minus c. I can kind of clean up the numerator and denominator here by using, distributing this negative into stuff, actually doing the subtraction, right? So this would be 3 minus 3c minus c, it will be minus 4c divided by c times 3 minus 3c in the numerator. In the denominator, I will have c, so if I distribute this through, it would be negative 3 plus 3c, right? So I'd have 4c minus 3 in the numerator, and in the denominator, c times 1 minus c. Okay, interesting. So this here, like this, and this looks similar to that previous problem we had, right? We can maybe do something with a negative here. So then if I want to simplify this out a little bit more, I could say, all right, the numerator, 3 minus 4c divided by c. Actually, why don't we take a 3 out of the inside here and be left with 1 minus c. And then the denominator is, if we flip it, it would be c divided by 1 minus c. And the denominator of the like this new, we're flipping this, right, putting it here, so that's going to be 4c minus 3. Okay, now we're not quite done here, because I could, well, we're not done yet, but we can be done pretty soon. Like right away we can see that these 1 minus c's are going to cancel, and so let's rewrite what we have so far. We've got c times 3 minus 4c divided by 3c times 4c minus 3. Okay, well, boom, these c's can cancel, and so now we've got 3 minus 4c divided by 3 times 4c minus 3. Why don't we just take out a negative from, it doesn't matter, either the top or the bottom. If we take a negative out of the top, we'd be left with 4c plus 3. Sorry, 4c minus 3. Okay, because if you take a negative 1 out of a 3, you're left with the negative 3. If you take a negative 1 out of negative 4c, you're left with positive 4c. So then we divide this by our 3 divided by 4c minus 3, and we can see those cancel, and the answer, surprisingly, is just negative 1/3. Alright, here's your problem I've already worked out. I challenge you to look through this and make sure everything makes sense to you. I chose to use the overall lowest common denominator in this problem, and I also chose to change m and n into x and y. The reason for that is that m and n look way too similar, and if you start using m and n in this problem, it will be very confusing. So this is a type of problem where, this is a type of complex fraction problem where if you can do it, and you totally understand everything that's going on here, you're golden for any complex fraction problem, because for the most part, they don't get a lot more difficult than this.